Hey everyone, this week the topic that you're going to be learning about is matter. And we're a couple of weeks into the course now, chemistry, and we haven't even really talked about what chemistry is. And chemistry is the study of matter and how it changes or its interactions. And so because we are just giving you that definition of what the course is about, we need to know what matter is. So a chemistry teacher, if you ask them and they say, oh, well, chemistry is all about learning what matter is and how it changes, the students are still going to be confused because you probably don't even have a solid grasp on what matter means. And really, the too long didn't read version is that matter is anything that takes up space, meaning it has volume, and has mass. A more technical definition, but still not the full one, is that matter is anything that is made of atoms or molecules, or the things that atoms and molecules are in turn made of. So after watching this video and taking these notes, you're going to go out and find samples of different types of matter. Now the reason we're learning about matter today is because, as I said before, chemistry is the study of matter and its interactions or changes. And so we'll look at a couple of ways that matter can be defined and types of matter. The most simple and typical definition that you'll find is that matter is anything that has mass and volume. And when you're trying to think of examples of things that are matter, you would think of the four typical phases of matter that exist on Earth: solids, liquids, gases, and plasmas. So a solid is something that has a definite shape and volume, meaning if you have something that is a solid and it's sitting there, it's not going to change how much space it takes up, and it's also not going to change its shape. A liquid, by contrast, has a definite volume. It's not going to change how much is there or how much space it takes up, but it will take the shape of its container. It will flow. A gas has no definite volume, meaning it can take up different amounts of space, and it has no definite shape. It will really spread out so that it takes up the space and the shape of whatever container it's in. And I have to specify that oxygen gas is only a gas at room temperature. There are temperatures where it could get so low that it would turn into a liquid. Plasma is a phase of matter where the particles that make it up are moving so fast that the electrons are knocked off of individual atoms and are not bound to individual atoms. And because of this, it will conduct electricity. An example would be lightning. Sometimes people get confused and they think that a flame is an example of plasma, but it's not. A flame is really a very, very hot gas that is emitting light. The electrons in the atoms of a flame are still bound, and a flame does not conduct electricity. So lightning or a spark, an electric spark, are examples of plasma. So these are all things that you might encounter. You're trying to think maybe of things that would not fit into this category, things that are not matter, and really it's waves and energy. So things like light waves, sound waves that still travel and you can see them are propagating through matter. Other definitions of matter, aside from it being things that have mass and volume, a more precise definition, though we haven't gone over exactly what this term means, atoms, but it would be anything that is made of atoms or the particles that atoms are made of, meaning protons, neutrons, and electrons. Now there's an even more precise definition because protons and neutrons used to be thought of as things that could not be split up anymore, but those are also made of smaller things. When you look at the standard model of particle physics, there are things called quarks, leptons, bosons, and their definition of matter would be anything that is made of quarks or leptons. Electrons are a type of lepton, and quarks, 3 quarks make up a proton and 3 quarks make up neutrons, just different types of quarks. The last part of the material today is going to be a flow chart that visually will represent how matter can be classified in the different types of matter. So again, the most general category is going to be matter. It's anything with mass and volume. Matter can be split into 2 categories, and those would be things that are pure substances and things that are mixtures. Now, a pure substance is something that cannot be separated by physical means. It has specific properties like color and density that do not change. And they are things called compounds and elements. The more technical way to describe a pure substance is it's something that follows the law of definite proportions. And what that means is that a water sample is always going to have the same percent by mass of hydrogen and oxygen. It always will have that, and it will be a defining feature. Its percent of hydrogen by mass compared to its percent of oxygen by mass. It is a definite proportion. Pure substances, like I said, can be split into 2 categories, and those would be compounds and elements. An element is the smallest unit of. Elements are made of atoms that all have the same number of protons in them. So an atom is the smallest thing that a specific element could be, and elements are defined by the number of protons in their atoms. For instance, if you pick up an atom and you count its protons very carefully and you find that there are 6, then you know that that atom is carbon for its element. Compounds are substances that are made from atoms of more than one element. A compound can be chemically broken down into its elements. Elements cannot be broken down through a chemical reaction. They can only be broken down or changed through a nuclear reaction. Examples of elements would be anything that is on the periodic table, and I had carbon before. An example of a compound that contains carbon could be sugar. It contains the elements carbon and oxygen and hydrogen. The subscript here refers to how many atoms of that element. So a glucose molecule has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So that is that definite proportion that we were talking about. Glucose always will have this proportion of carbon to hydrogen to oxygen. Now we'll move on to mixtures. And a mixture is just 2 or more pure substances mixed together in any type of ratio or proportion. They do not have to follow the law of definite proportions. In addition, mixtures can be separated through physical processes. So things like filtering or distilling are physical processes, ways to separate different components of a mixture. Mixtures can be 2 types, whether they are mixed evenly or whether they are clumpy or lumpy, and those would be homogeneous and heterogeneous mixtures, respectively. We usually think of these things as being something mixed into a liquid or mixed into water, but it works for other phases being mixtures as well. If you have 2 granular solids that can be mixed together, that could be a mixture and it would be a heterogeneous mixture. If you had 2 gases that were mixed together, they probably would form a homogeneous mixture. But we're going to, for our examples, look at things that are dissolved in liquids or dissolved in waters. Homogeneous mixtures are evenly mixed. They are called solutions. Heterogeneous mixtures are not evenly mixed. They have pockets in them where there is a higher concentration of one of the components of the mixture. Contrasting to the term solution, where something is evenly mixed, a heterogeneous mixture can sometimes be called a suspension or a colloid. One way that you can tell if something is truly a homogeneous or a heterogeneous mixture, especially if they're dissolved in water, would be if the solution has a laser shown through it, it would not scatter light. You would not be able to see the laser beam. Versus a heterogeneous mixture, because there are suspensions or things floating around in the water that are not dissolved, you would be able to see the laser beam through it. An example of a homogeneous mixture would be something that does dissolve into water very easily, things like sugar water or salt water. Examples of heterogeneous mixtures would be things like milk or oil in water when you shake them up, or starch in water. And from those examples, you can see that they do not follow the law of definite proportions. You can have sugary water. So just saying to someone that you want some sugar water does not tell you a definite proportion of sugar and water. Sugar water could be any range, any ratio of sugar to water. And so, again, mixtures do not follow the law of definite proportions because they could have any amount of the different components in that mixture. Now, to illustrate this last point about a homogeneous mixture and a heterogeneous mixture, I've created 2 solutions. This one is salt dissolved in water, and this one is some starch put into water. Now, I'm being careful with my words. You wouldn't say that starch dissolved in water because then it would be a solution. This is going to be more like a suspension. You can see the difference with this laser pointer that I have. If I shine it, you can see it on the cup, and as I move it down into the solution, very faint beam moving through, really because of undissolved salt. If I were to give it more time, that would become even more and more faint, and because of the bubbles as I was stirring it. So there are bubbles now and there making the laser beam show. But you can definitely see a clear difference when I shine the beam into the suspension. You can see the beam all the way through. It's hitting the starch molecules that do not dissolve in water. You can see now as the bubbles have settled, really no light being scattered, or you can't really see the beam anymore through the salt water. So hopefully all that stuff about matter was clear enough, and it's going to let you go out and find your own samples of different types of matter, of homogeneous mixtures, heterogeneous mixtures, pure substances, elements. One thing to remember though, don't trust atoms because they make up everything.